Now, in the near future, we are going to deal with a lot of fractions. I mean, a lot of exponents. Okay, and I think it's a good time to start understanding something very simple, and that is, back in Algebra 1, you might have learned some rules, which would be, when do you add exponents together, and when do you multiply exponents together? I like to use these two examples, okay, to illustrate something very fundamental. The concern that I have is that some of you, if not all of you, were just memorizing the rules, trying to get a good grade on the quiz or test, and not understand the meaning. And that's my primary concern. So now, ask yourself, do you know the rule? Do you know the why of the rule? So, for example, if you look at the top one, what would the answer be? Would it be x to the fifth or x to the sixth power? Ask yourself, okay? I'm going to place these two answers for both answers, for both questions. Is it x to the fifth or x to the sixth? Let's have a show of hands. For the top one, how many of you think it's x to the fifth power? How many of you think it's x to the sixth power? Okay, but why is it x to the fifth? You add the exponents, right? But why? Now, this why question is very important because you need that to reassure you that you're on the right track. This is simple, nice looking exponent, or exponents in this case. But in the near future, you are going to see fractions in the exponent position. Now, we'll get to the meaning of the fraction, the exponents later on. But I need you to have a firm foundation of why the rule is such. Any suggestion why we're adding exponents?
You get x, because x squared is x times x.
I love it. I love it. I love it. This is the meaning, okay? My primary concern is that some students, they would just say, oh, because it is multiplying, so we add the exponents, and using that as an explanation. That is not an explanation because it explains nothing. That's just a statement that you use to memorize the rule. That's not an explanation, okay? All right? It's just like asking the question, since I was a chemistry teacher, like, why is water liquid? And you would say, well, because water flows, so it's a liquid. Well, that's the property of a liquid. That doesn't explain why water is a liquid. Okay, you would say that, oh, because the H2O molecules are strongly attracted to each other, so they are closer together, not like gases, but it's not strong enough to be like a solid. So you look into the, molecular structure and what's going on between the molecules. There's a reason. Well, same thing right here. The reason why we add, not because they're multiplying, so we add the exponents, is because the meaning of this expression, well, x squared means x times x. X cubed means x times x times x. Therefore, we have a total of 5 x's multiplying together. So therefore, it's x to the fifth. And for the bottom one, is it x to the fifth power or x to the sixth power? X to the sixth power. But why? Why do we multiply these two exponents together? What's the meaning behind it? Because the meaning of cube is to multiply by itself 3 times. So the other way to write this would be x squared times x squared times x squared, which means that you have a total of 6 of the x's multiplying itself. Therefore, it should be x to the sixth power. So if you think about these rules, I want you to change the way to think about these rules, okay? I want you to think about that there was no rule to begin with, but you understood the meaning, such as these and these. You understood the meaning, and then you discover a pattern. You discover a pattern that, well, if that's the meaning, we will have x to the 6. But wait, look at these two exponents. Well, guess what? It seems like the pattern is to multiply these two exponents together. Change the tone, change the narrative. Instead of forcing yourself to memorize something, pretend that you created something. And that would be a very powerful move to explain to yourself why on earth we're adding or subtracting, or why on earth we're multiplying or dividing exponents.